Hello students. In this video we will go over Chapter 2, various measures of centrality and measures of variability. So in Chapter 1 we talked about tables and graphs. In order to summarize data, what we're going to be doing in this chapter is looking how to perform additional analysis of data sets. We're going to start with measures of centrality with the mean, and there's various types of means or average, and then the median and mode as well. So the first thing we'll look at is the mean, basically calculating an average. So we have this data set on page 26 of your course package. I'm going to be doing it in Excel. However, for the review questions for this chapter and for the exams, you'll need to do it on paper. So we look at this first data set. We just want to calculate a simple average. Here's our data set. Basically, you add them all up. So I'll do it that way. We add all those values up, and then we take that and divide it by 8, because there's 8 values in there, and we'll get an average of 9. We can also do that with the Excel function equals average. Highlight all your data, and there is the average of 9. So that is something relatively straightforward. You've been doing that calculation before. That is the average. The weighted mean, calculation that we will be doing quite a bit of. This value occurs when some values appear more than once. So we have this example. So we have a class, there's 8 students, 5 students received a mark of 80 and 3 students received a mark of 60 on the test. What was the weighted class average on the test? There's 2 marks. Most students got 80, some students got 60. You can't just take that average of 80 and 60 and get 70 and think that's the average, because there's more students who scored 80, so that grade is weighted more. So to do this, I'm just going into Excel again here. Let's go near the bottom. So a couple ways to do this. We can go like, okay, we can just add or enter the 5 grades from the students who got 80 and then the 3 that got 60. We can add that up. We get 580. There's 8 students in total. We can take that sum, divide by 80 as well. We get 72.5, slightly more than the average of 80 and 60, or the middle value between 80 and 60, 72.5. Another way of doing this, the easier way of doing this, is we have the 2 grades, 80 and 60. We have 5 students that scored 80 and 3 students that scored 60. We know that there's 8 students in total. So we need that value. That's the total number of items in our small data set. We can multiply across the 5 students who got 80. Gives us a total of 400. We can do that again. I'm just going to copy that down, that formula down. And there's 3 students who got 60, which gives us a total of 180. We can add those 2 values together, and we get 580. 580 divided by 8 gives us this 72.5. So 2 different ways to calculate that weighted mean. The second example, there's 120 students who wrote a test and basically received values ranging from 4 through 10. Hopefully this is a test just out of 10. So some students got 10 out of 10, some students got 4 out of 10, and various range in between. We can answer the same question: what was the weighted class average on the test? Let's look at the breakdown of it. So there's our test scores. We have 4 students right there, or a test out of 4 out of 10, 3 students got that grade. That 17 here means that 17 students scored 5 out of 10, 1 student scored 10 out of 10. So we don't have all, actually one way we can do this is just jot down all the scores for all 120 students, but that's going to take a long time. So let's go up here. Here we have the data set. We have 3 students that scored 4. We got 17 students that scored 5. Basically multiplying the X value with the frequency, and we'll get a weighted test score for those students. In Excel, we can do this quite easily. On paper, pen and paper, you'll have to do this by hand. So this, we have 17 students that scored 5, gives us a weighted value of 85. We have 45 students that scored 7 out of 10, gives us a value of 315. We want to add up the frequency. We know there's 120 students. So we also want to add up the weighted test score, the product of those FX values, and we'll get a value of 815. So in this case, we would go, I'm just going to show this out here, 815 divided by 120. That would be how we would calculate the weighted average. So let's do this just to give you that final answer. 815 divided by the total frequency gives us an error message. Why did I get an error message? Oops. B9. There we go. The average was 6.79. So about 6.8 was the average test score for all 120 students. Common type of weighted calculation occurs in some college classes. You may have some of your courses that are weighted more. The credit for each class might be 4 credits or 5 credits. Most course credits, or most credits in courses at Red Deer College have all been standardized to 3, but there still may be some courses that are worth more than the typical 3 credit. So in that case, those courses are weighted more. So you can't just take the grade in this last column here and add those up, divide by 4, because the credits are weighted differently. So in this example here we got the credit, and here we have the grade. So we're going to follow the same process. We're going to take that credit, which is the actual frequency, times the grade, which would be the value of X. We're going to do that for all 4 courses. And we need to know how many credits there are. So we need this sum, and there is 15 credits. Let's just color that so we know that. 15 credits. We want to calculate the average of that weighted value, and we get 1209. So in this case, we're going to go 1209 divided by 15, and that'll give us our average in those 4 courses. So let's go 1209 divided by 15, gives us an average of 80.6. Now, just to change things up, if all of those 4 courses had the same credit weight, say they're all weighted 3, the average, we don't have to really do a weighted average because everything would be the same. So I'm going to change it here, and we can see the change going around here. The average now is 79.75. That average would be the same as if we had just calculated the average of those 4 courses. 79.75, and we can verify that. We can add up the grades of those 4 courses, and just divide by 4. We get 79.75. So the difference is when they are weighted differently, you can't just divide by the total number of courses. You'd have to divide by the total number of credits. So let's change this back. Stats, of course, is most important, so it's weighted 5. Accounting, had to put a 4 in somewhere, I guess. And everything there's our weighted average of 80.6. So you're doing well in stats, it brings up your average because it's weighted more. And that's a life lesson as well. The mean of grouped data. So the data set has been placed in groups or classes, similar to what we did in Chapter 1, where we would take a large data set and we would create different classes using the Sturgis method and then do a frequency count of how many items in the data set go within each class. What we have to do in this next step is to calculate a middle value or midpoint for each class. So let's look at this example here. We have weekly wages earned by various employees. So the weekly wages class, 360 to under 400, and then 600 to under 640, and a different number of employees who indicated that that's what they earned in their last week. So we could probably do an estimate. We know that perhaps the average is going to be between 400 and 480, maybe something closer to that 480 value. So what we have to do in this case is, because we can't multiply frequency by the weekly wages class because there's really no number in there, what we have to do is calculate this midpoint. So let's go into this, back into Excel. So we have our classes listed here, 360 to under 400. We need this class midpoint, the middle value as indicated by that class. So we have two values. We have the lower limit of 360 and we have the upper limit of 400. And basically we can just add those two endpoints together and divide by 2. And we get a midpoint of 380. So I need everything centered in my life there. 380. We do the same thing for the second one. We have a value of 400, upper limit of 440, and our midpoint is going to be 420. One thing you should be able to do, kind of visually here, mentally, is determine the class width. The class width is 40. We have 360 to under 400. We have the difference of 400 to 360. It's going up, the lower limit is going up by 40. The upper limit is also going up by 40. So that makes sense that the midpoint is also going to go up by 40. So I'm just going to apply a quick little formula in there. And there is the other midpoints. We can verify the last one. 600 and 640 would be the upper limit, and our midpoint is 620. The class midpoint, the weighted class midpoint now is F times the midpoint, or that X value. So I may have indicated this in some other examples as a F times M value, M being the midpoint. So we just multiply these values across. This becomes very similar to the weighted average type calculation. The only difference is we did need a midpoint value to calculate. So how many employees do we have? We need to add up that frequency. Have 195 employees. We need to add up the last column. We get that 91,540. So in essence, the weighted weekly wage earnings would be 91,540 divided by 9, divided by 195, and we will get this value. Let's do that. So we get just under 470, 469.44. So the difference, what we have to do here is calculate this midpoint, and then once we have that midpoint, that X value, or as I said, the M value in some other examples, we calculate, multiply F times M, and then we add that up and divide by the total number of employees we have, or the total frequency.